Tanner?
Yes.
You're okay with that? Okay. Alright, so 2-3 is all about sketching curves, okay? So they are going to give you some gnarly functions and ask you some very specific things, such as the domain, okay? So we've been talking about domain. What are the 2 ways to restrict the domain? What are the 2 ways to restrict the domain? Yeah. X in the denominator, can divide by 0, and
When there's a square root.
a square root. Right, good way to read that, very good. Okay, we're also going to be identifying our vertical asymptotes, okay, which is another scenario of when the x is in the denominator, but there is not the same quantity on the top. Holes are created when you cancel quantities out, so we'll go over examples of that. We're going to find x and y intercepts, and we're also going to talk about end behavior, okay? So this is kind of a newer concept. We did talk about this in pre-calculus. So end behavior is like, I'm going to become the function with my hands at the very end, and you have to tell me what's happening. So like, if you're a parabola, the right and left end could possibly be going both up to infinity. If you were a John Travolta, your right would be going up, left would be going down. So we're going to talk about both of the ends. So they could potentially be the same value or different. And then, of course, even and odd, so symmetry. Okay, so let's start with number 1. We're going to start by giving the domain of this function. Okay, so before I start this, what I'm going to do is I'm going to play a little bit with the function. Okay, if you notice the bottom can be factored, what can I pull out? I can pull out an x. Oops. So I have an x and an x minus 2. Okay, so now this becomes helpful because now I can easily find the points that x cannot be. What are the 2 values that x cannot be? Okay, so I'm just going to say x cannot be 0 or 2. Okay, and that's going to identify our domain. Okay, vertical asymptotes. Do I have any vertical asymptotes? There are 2 vertical asymptotes, and where are the 2 of them?
0.
0 and 2. Okay, so they're places where you have discontinuity. We know they're at 0 and 2 because there is not an x on the top for it to cancel with, or an x minus 2 on the top for it to cancel with. Okay, so if that is simplified, still on the bottom, then that's where vertical asymptotes happen.
Why negative 2?
No, that's from the top. You only look at the bottom. So I'm looking at the x minus 2. All right, so end behavior. Okay, so there's kind of two ways I'm going to think about this. I'm going to start by thinking about horizontal asymptotes. Okay, so if I look at this and I go back to the original, which case is this? Is this bigger on top, bigger on bottom? Bigger on bottom. So where is the horizontal asymptote? 0. So what is the end behavior of this function?
Right.
Okay, let me say that one more time. If I have a horizontal asymptote at 0, the function is getting infinitely close to 0. What is the end behavior of this function? Where is it going?
It's like this.
Where are those values going? They are going to 0. Okay, so both the right end and the left end, I'm going to just say this, both, are both going to 0. Okay, so we could graph that on the calculator. You want to graph it on the calculator, see what it looks like? Let me see. I disagree with your function. You got to put the top in parentheses. And the bottom.
What is h red x?
Wow.
Sexting of clouds.
So this is what it looks like, by the way, for those of you guys that want to see what it looks like. Okay, so it kind of looks like a sad face. Okay, so you can see as these end behaviors right here.
What is RE/LE?
Where are you looking at? Oh, right end and left end.
Okay. And then I have a question. How do you find this word class?
The values that make the denominator 0.
Okay.
Okay? All right, number 2.
Do you know the? How do you know that the thing in the middle is supposed to be up top?
I graphed it in the calculator. That's how.
That's
The only other way is I would pick values in between there and find out. So I could throw 1 into the function and see if I get positive numbers or not.
So the next one, since it's bigger on top, it'll be infinity or negative infinity.
Okay, first let's talk about the domain. What's the domain of number 2? What's the value that x cannot be? -3, so we're looking at the denominator. X cannot be -3. Vertical asymptote. Okay, there is one at -3. Okay, in behavior. Okay, is it bigger on top or bigger on bottom? It's bigger on top. So what does that tell us if it's bigger on the top? It's a slant. Okay, so we know that the right hand is either going up to infinity and the left hand is going to negative infinity, or the right hand is going to negative infinity and the left hand is going to positive infinity. How are we going to decide? Okay, let's just do the sign test. I don't think we need a calculator to figure that out. Okay, let's do the right end and do a positive number. If I plug a positive number in, on the top I would get a positive over a positive. Okay, so the right end goes to where? Positive infinity. Where does the left end go? Negative infinity.
Wait, how do you know that was the right?
I had to wait. What?
How do you know that was the right?
Because I plugged in a positive number. A positive. So if you go back to the original and you say, if I put a positive number into 2x cubed, what kind of number would you get out? A positive. And then if I go to the bottom, if I plug a positive number in there, I get a positive out. So if I have a positive over positive, that's a positive. It's going to positive infinity. So I know the left hand was going down. Because of the slant asymptote. I know there's a slant. So it's like this. Okay. Number 3.
What's H red X?
I'll explain that. Let's do domain first. Okay, what are the 2 values that x cannot be? -2 or +2, right? So we're looking at the bottom. Okay, now hopefully you look at this function and notice something. Okay, what do you notice about this function? They factored it, but also what else? What if I have an x minus 2 over an x minus 2? Yeah, there's a hole there, and it simplifies. So what they're asking us to do with that h of red is they're asking us to simplify the function. Okay, so if I simplify that, I would be left with x plus 4 over x plus 2. Okay, and the reason they want us to do that is because that helps us identify the difference between a vertical asymptote and a hole. Okay, so after I simplify, what's still left in the denominator? What discontinuity do I still have?
-2.
-2. So that means I have a vertical asymptote at x equals -2. Okay, the whole comes from the quantity that I canceled out and simplified. Okay, what value would make x minus 2 0? 2. So there was a whole at x equals 2. Everybody understand the difference between holes and vertical asymptotes? Algebraically.
Why wasn't it at -2 the whole? Because you cancel out 2 x minus 2.
Right. I canceled out x minus 2's. The quantity I canceled out is where the hole exists.
So x.
X minus 2. 2 minus 2 is 0.
So it's 0 over 0?
Right.
I
Right.
thought you said that was it.
How do you get it at 2?
How did I get it at 2? So the 2 quantities that I canceled right here, That's where the hole exists. Okay, so end behavior, I'm going to go back to the very original one. I'm looking at this x squared over x squared. What do I know about x squared over x squared? Which horizontal asymptote case do I have? Okay, good. So are the same. So the value in front are at 1. No, it's at 1. So both the left and the right are both going to 1. We're going to level out. You don't get that? So see how I have x squared over x squared on the very top that I circled it? So that's the case where they're the same. So what's the value in front of x squared and x squared?
Oh, they're the same.
They're the same, right?
What does it mean if they're the same?
It goes to the numbers that are in front of those numbers. So if I have x squared over x squared, there's 1 over 1. Okay? All right. So this is what you're going to be doing when you sketch these. So this is a sketching recipe. Okay, so this would become helpful for you. Sometimes they'll give you this information and sometimes they won't. Okay, so you want to understand what the domain is. You want to reduce the function because that will be what it looks like. Find intercepts, end behavior, and symmetry.
Yeah, I'd probably find a starting point.
Yeah, it depends on the kind of graph it is. It is a lot to do. Are you guys ready? Okay, here we go. Number 4. First ask us for the domain. What is the domain of question number 4? Okay, is there any value in the denominator that makes the value 0? There's no denominator, right? So what's my domain? All reals. Okay, how do I find the x-intercept? That's an all real. It's an R with 2 lines. No, how do I do it algebraically? Set y equal to 0. Can we look at this and say if I set that equal to 0, it's in factored form? Okay, what are my zeros? Are my x-intercepts? Same thing. X equal 0, 1, -2. Good. Okay, now when I do this, what I want to be looking at is at each of those quantities, I want to be looking at the exponent because that tells me something about the graph. Okay, if you have an odd exponent, that means that the function crosses through the x-axis. But if you have an even function, that means that the function is going to bounce. Okay, so which of these values is it going to bounce at? Which one has an even exponent?
2.
2. -2. Okay, -2 is going to have a bounce at it. Okay, I would write that down. Okay, it's very important, very helpful when drawing this graph. Okay, how do I find a y-intercept? Plug 0 in for x. Can we all go if I have 0 times anything, it's still 0? Everybody okay with a y-intercept of 0? Okay, end behavior. We can figure this out. Okay, if I was going to figure out how many x's are involved in this, I have an x in the front, then another x, and then an x squared. So really this is an x to the what? 4th. X to the 4th. What kind of function does an x to the 4th look like? It's an even function. It looks like a parabola. Okay, so tell me about the end behavior of a parabola. They both go to positive infinity.
That's assuming parabolas.
Positive. It is positive. I know for a fact it is. I can see the equation. Okay, so then I'm going to plot my intercepts. So I've got one at -2. I've got one at 1 and one at 0. Okay, so this is going to be a parabola. I'm going to bounce when I hit -2. Hold on, give me 1 second.
For me? And then it's good.
Okay, wait, hold on. Don't leave yet. Okay, what?
Make AP stats your highest course.
Oh, just move those? Okay, that's easy.
You know, so if they go,
Right, because they could go there.
yes, they go either one, but then it's showing that your highest courses are always your AP courses.
Okay, yeah, that's easy.
And then this one, they can go here to here.
Here to here, okay. And there, right.
They can go in
But I also can say advanced algebra to stats too. even though I don't think there's enough years to do that.
-2, 3.
Wait, even though it bounces?
But and statistics.
Go either way, they could choose either one.
Okay. Got it.
All the options.
It's a lot of arrows. That's a lot of arrows. All right. So how do you guys like my graph?
How do you know to balance it?
Because of the even exponent. So see how that quantity has x plus 2 squared? That means that it's a bounce.
Why?
Why not?
Why is it like that?
Because, okay, so think about a value that you'd plug in. Okay, so like if I plug in a positive number and I square it, it turns positive, right? So any value that's close to that is going to be a positive number.
We could.
Does that make sense? Because I'm squaring it, and anything that I square turns positive. No? That's why, though. Because if I plug in a number right there, it will turn positive.
So why is
Because
that
I
even
squared.
balance? Is it because the 2
Well,
it's 2?
it's bouncing up, right, into a positive area, right? Anything above the x-axis is positive. The y value is positive, right? No. Well, that's why. We could go further. I don't know. We'll talk about it later. Is that right? Okay. Let's do number 5.
Yeah, please.
It depends on the graph. Like, I would expect for question number 4 that you could handle that without a calculator. But question number 5,
Can we do it with
not so
calculator?
much. We'll see. We'll see.
So how would you know how to deal with that?
For number 4? Well, you know that it's an x to the 4th. It looks like a parabola. So you know the end. You know it bounces at -2. So I'm going to start up. I'm going to go to -2. I'm going to bounce up. And then I'm coming back down. And I'm going to cross through 0. How, when you cross and when you don't? Through 0 and 1. Because they have odd exponents. So even is a bounce, odd goes through. All right. Okay, question number 5. Ready? Let's talk about domain. What are the values that x cannot be?
0 and 1.
0, 1, 3. Oh boy. Okay, so this one is one that can be simplified. Okay, I've got an x over an x squared, which leaves an x in the bottom. I have x minus 1 squared over x minus 1, so the 1 in the bottom is going to cancel. I'll still have an x minus 1 on the top. And then I still have x plus 3 cubed and x minus 3 squared on the bottom. Everybody okay with that simplification? So just reducing, cancel out what's on top and on the bottom. Okay, so now once I've simplified, I can figure out where my vertical asymptotes are. Okay, where are my vertical asymptotes? 0 and what else is on the bottom right now? And 3. So I have vertical asymptotes at 0 and 3. Okay,
1 and 1.
because I canceled that. There's a hole at 1. Okay, so the other point of discontinuity, remember my domain, I have one at 0, 1, and 3. So if 0 and 3 were vertical asymptotes, that tells us what about 1? It's a hole. So there's a hole at x equals 1, and that's very interesting.
Very interesting.
You'd be surprised. Okay, x-intercepts, this is not too bad. If I set my y equal to 0, I basically can kill the idea of the whole denominator because you would essentially multiply that times 0. So I'm looking only at the top. What are my x-intercepts? What? What values make the top 0?
Plus 1.
0, 1,
And negatives. Plus
Mm.
1.
just -3. Only -3. Because
Do
it's
you have
x
to worry
plus
about
3.
that exponent?
Nope. I could think about it though. I could think 1 is going to have a bounce. No, it's not. I lied because it's. Never mind. because it's simplifying, because there was 1 on the bottom. There's not a bounce. Because you have x. Yeah, the original.
But 3 is odd, so wouldn't there be a bounce at 3? Like x plus 3?
What?
Wouldn't there be a bounce at? Oh, there'd be a bounce at.
So you're looking at the top. Oh, no. Okay, hold on. No, there is not. So wait, okay, there is not a 0 at. Not a 0. There is not an x-intercept at 0 because there's a vertical asymptote. Right? So not at 0 because there's a vertical asymptote. Okay, so for bounces, we want to look at the reduced one. X minus 1 is odd and x plus 3 is odd. So it's going to cross through on both of those. So there's no bouncing on this one. Okay, what's my y-intercept?
There's not a bounce at 3. -3 though?
Nope.
Because of squared?
Because it's cubed. It's cubed on the top. You're looking
Yeah,
at
but
the
what
top
about the
one.
denominator?
But that's not an x-intercept. Those are points of discontinuity. Intercepts are on top. Points of discontinuity on the bottom.
So only if an exponent's even or odd on top.
That causes bounces. So on the bottom with the 3 on the bottom, that's going to be an even. So that's like where, like the volcano effect, you know, like where it goes like this, it reaches it. That's the vertical asymptote that's going to happen. So like this right here, whoops, is even. So the function is going to get close to 3 on both sides, or like this. Okay, y-intercept, there is none. There is a vertical asymptote at x equals 0, which is the y-axis. There is no y-intercept. Okay, and behavior. So I have to go back to the original and figure out what my biggest exponent. So on the top I have an x, I have an x squared, that makes 3, and then I have x cubed. So what do I have on the top? To the 6. On the bottom I have x squared, that's 2, an x, that's 3, x squared is 5, so I have x to the 5th. Oh. So, which case is this?
Don't worry about it.
Bigger on top, slant asymptote. What's my end behavior? No. What's my end behavior? If I plug in a positive number into the top, what would I get out? Think right up here. I get a positive over a positive. So right end goes to positive infinity, negative.
Left end goes negative. I could have told you that.
Oh, good. All right, so I'm going to start by drawing my asymptote. So I got 1 at 0. I've got 1 at 3. I've got intercept, so I've got an intercept at 1, but actually is a hole. So I'm going to draw a hole like that. It's going to cross at 1, but it's going to actually be a hole. I have 1 at -3. And pretty much at that point, I don't really know what's going to happen. I know that the right end is going to go somewhere up to positive infinity, left is going to go down, but I don't really know what's going to happen in between there. So, there's no y-intercepts. No. No bouncing. Crosses on all of them. Alright, so this one, I'm going to use my fraction. So we got x times the quantity of x minus 1 squared. X plus 3 cubed. We got x squared, x minus 1, x minus 3 squared. All right, we ready? Okay, so that one kind of has sort of like a John Travolta effect on the left, but it like kind of, it goes this direction. Like that. Super crazy weird. Okay, and then in the middle, it's like a super duper steep John Travolta that crosses at 1, although there exists a hole right there. Okay, and then on the right-hand side, now you can't see this, so I'm going to have to zoom out. I know that it should come back down like this, because remember that it's an even asymptote, so it has that volcano effect. But I know it also has to go up to positive infinity, so it's going to come down and then go back up.
What would ever cause a graph? Oh, this is so real.
I don't know.
No, I'm telling you, if
I don't know.
graph that, I never would
I don't know. All right, ready? Last one. Let's try to nail through this one. You guys are dragging. You guys need some coffee.
You need not.
This is the last problem. Okay, domain, what value makes the denominator 0? Good, 0. Holes? No, wait, yeah.
How'd you get
Holes. What?
that? How'd you get zero? Yeah.
What value makes the denominator 0? Okay. But it's got to be greater than 0, right? Okay, because we have a square root, so this has to be greater than 0, and it can't equal 0, because it has a square root, right? Yeah, anytime you have square root involved too. So this is both. -1 plus, well, you can have 0 on the top. That's okay, because 0 divided by anything is still 0, but you just can't divide by 0. Okay, so, vertical asymptote. Do we have a vertical asymptote? Yep, 0. Do we have a hole?
Nope.
Did anything cancel? No hole. X-intercept. If I take the top and set it equal to 0, what's the value that it makes it 0? -1. Y-intercept. If I plug 0 into both x's, you get 0, so you get none, because there's a vertical asymptote at 0. End behavior. Okay, so this is where I'm thinking about the horizontal asymptote. So this is the case where I have x over, if I have the square root of x squared, that becomes the absolute value of x. Okay, so this is going to be where you have 2 asymptotes. Okay, so which case is this? Is this bigger on top, bigger on bottom, or is it the same? Same. So where is my asymptote?
In front.
What's the numbers that are in front? 1. Okay, so there's 1 at 1, and there's 1 at -1. Okay, so 1 at 1.
Because it's positive, and then you have to plug in
Right.
one of them to decide which one.
Right.
Positive number.
Okay, so if I plug in a positive number into the x, I would have a positive over a positive. So my positive infinity, my right end, is going to go to positive infinity. No, +1. Ooh. Excuse me.
And left hand will be negative.
So then left hand will go to negative. Yep. Okay, so starting point, I'm not going to do the starting point. I'm going to draw my asymptotes because I'm going to show you what this graph looks like. I'll show you why. So vertical asymptote, I have a vertical asymptote at 0. Because I don't even know where that starts, to be perfectly honest. Well, I guess starting point would be at your 0, the value just bigger than 0. I don't know. We have 2 horizontal asymptotes. We had 1 at 1, 1 at -1, right? We have a x-intercept at -1. Did I graph everything? And we have no... Okay, I think we got everything. Okay, so now we can use the calculator to help us. Well, sometimes you can't help it.
As a horizontal asymptote.
Okay, so this kind of looks like, it kind of is like the volcano, but one end is a little bit lower than the other one. Okay, so this end starts at -1 and goes up to that asymptote, doesn't touch it. The left side does the same thing, but only goes to +1. We probably could have figured that one out, actually, without a calculator. Okay?
Does this get,
Yep, it has 3 asymptotes, in fact.
Well then, why does it pass right through when it's asymptotes? That one go. All the lines
yeah,
have
that
to-
wouldn't that not be an asymptote?
Yeah, and I guess that's kind of a good point, because that one on the left does cross through 1, but it's going to the asymptote -1. So when it comes to horizontal asymptotes can be crossed, but they're kind of like a rare case where in the long run I'm going towards an asymptote, and it depends on where I'm at. So like things that are divided by vertical asymptotes. So if I have a vertical asymptote and if I have 2 horizontals, this one is either going to ride one of those horizontal asymptotes. If I have another one, like you've seen the John Travolta that kind of comes down through
So
them.
it follows one.
So horizontal asymptotes are crossable.
That's what.
Yeah,
What is VA?
vertical asymptote. Where do you know where the horizontal? So you have to look at the exponents. So if it's bigger on top, bigger on bottom, or the same. How do I stop this? All right, so I want you guys to go through number 28. Okay, so 1 through 28 is your assignment.
What was our assignment? And what's my grade?
Finish 2-1 and 2-2. What's a 5-point assignment? I don't know. Oh, there's the one. Oh, that's hard to find.
What was it? Finish what?
The Monday one?
Yeah,
Finish the 2-1 and the 2-2.
that's like
We have like
80
seven, yeah, I feel like we should know.
Oh, that's so.
There's so much, I'm gonna have
Oh,
like
you
3.5
guys are-
hours of homework.
3.5 hours?
Yeah, because I have so much.
How come you didn't come see me on Monday and say, hey, what's the assignment?
Yeah, I got the assignment. Well, because you said we're in school, I do have other classes that I just want to do now.
Alright, so there's 2 on